Hello everyone, welcome to our channel Code with Sunny, and today we will be discussing the simple problem. Although it is a medium, I will consider this as the easy problem. We have to rotate the array, and rotating the array we need to shift all the elements to the right by k steps. Okay, so as the problem suggests, given an array, rotate the array to the right by k steps where k is going to be non-negative. So I will explain it out how we are going to be done. So first let's look over the constraints. You can see max size of this array is 10 raised to the power 5, and the elements of the array doesn't matter because we have to shift the elements, not to change the elements or to perform some operations. And k is going to be like less than or equal to 10 raised to the power 5. Okay, so there is a follow-up also. Can you do it in place, that is with O of 1 extra space? Okay, so let's understand this problem first. Suppose we have been given some array, let's say 1, 2, 3, 4, 5, 6 and 7. These are the elements of the array, and let's say k is given as 4. So it means that we have to shift all the elements to the right by 4 steps. Okay, so let's focus over this element. So we have to shift this 1 to the right by 4 places. So this is 1 place, and this is 2 place, and this is will be 3 place, and this will be the 4 place. So you can see the distance 1, 2, 3 and 4. So we have to shift the each element to the right by 4 places. So the new position of this 1 would be over here, and if you follow the same thing for 2, 3, you will get that the new position of 2 will be this one and new position of 3 will be this one. Okay, now these all elements have their after moving their k steps to the right will be placed over here. Now what about this 4? You can see 1 step, 2 step, 3 step, and when you rotate this array by k steps to the right, you can see this 4 will jump over to the very first position. Okay, so it means that the position of this 4 would be over here, and the next element is 5, so correspondingly 5 would come over here, then 6 and then 7. Okay, so these are the positions of the elements, that is their new positions. You have to shift every element to the right by k steps. Now you can easily understand that if you take an extra array and perform the shift like array of I must be exactly equal to okay, so we have to modify this nums. So I will take an extra array first, and so nums of I exactly equal to array of I minus k, and provided that we need to take a modulus sign also, modulus n. So this will be our answer if you take an extra array and store all the elements in this array ARR. Okay, so this will have the complexity of O of n time and O of n space. This will give you the correct answer. I think one of my code does the same. Okay, so let's look over that. Yes, I have taken nums of I exactly equal to array of I minus k plus n mod n. Okay, so I make a copy of this array nums in this ARR, and just I've done the same. Note that you need to take a modulus with n for the value k, because it may exceed the length of the array nums, right? So that's why we have to take the modulus sign. Okay, but I don't think this should be an good way to solve this problem, because there is a follow-up also. We need to solve this one in O of 1 space. So how we are going to do that? Okay, so let's consider this the same example. So let's try to do some work. You can see that 1, 2, 3 comes from this position. Okay, so that is you need to be careful that we need to move every element to the right by k steps. Okay, now you can see that this 1, 2, 3 will be jumped to this position, this 1, 2, 3. Okay, so it means that first we need to figure it out how many elements will occupy just to the end of this array. Okay, so let's write down this thing as for every element I, belongs to 0 to let's say, okay, so let's generalize this case. Okay, so we have been, let's say we have the positions as 0 1 2 3 4 5 and 6. Okay, so 0 goes to 0 plus 4, and 1 goes to 1 plus 4, and 2 goes to 2 plus 4. Notice that when this index, that is 2 plus 4, comes out to be 6, still it is in the range of this position, right? Now what about the element index 3? 3 plus 4 exactly equal to 7. Now here is the case, our index like 7 doesn't exist in this array. So first we need to find that range which gives the elements, that is their new positions within this array. So in general we can write it as, first I am going to write it down and I will then explain. For every I belongs to 0 to n minus k minus 1, and for every I that belongs to this position n minus k to n minus 1. Just think about that. For every I that is going to belong to in this range will have their new positions as I plus k directly, and for every I that belongs to this one will have their new positions as I plus k mod n. Indirectly you can also write it as I plus k minus n. Okay, you can see that if you fill out the value of k over here, it is 4. So my new right bound would come out to be 7 minus 4 minus 1, which is actually 2. You can see up to the index 2. You can see for every 1 2 3 you have their new positions as I plus k. Okay, so in that case you can easily just do the operations as I plus k. Otherwise you are going to do the as I plus k minus n. Okay, now how we are going to do this in O of 1 space using this concept? So let's try to understand. Okay, so what we are going to do is, like, let's focus over these three positions. So let me first erase it out. Yes, you can see that for these elements 1 2 3, let's consider it as a vector like over this position. Okay, so let's call this length as k1, and you can see this vector consisting of 4 elements as k2. Okay, so you can see k1, length of k1 is going to be what? N minus k minus 1 plus 1. This should come out to be n minus k. You can see if you verify it, 7 minus 4 will come out to be 3. You can see this will say, why, how can I am how am I writing this one? You can see the length of this arrays, length of this prefix will always be 0 to like the range would be 0 to n minus k minus 1, and for the other range it should be like n minus k to n minus 1. So what is the length of this range? Length of this range is n minus k minus 1 plus 1. And what is this length? N minus 1 minus n minus k plus 1. This would be the length. Okay, so I'm not interested in the length. Okay, so for now let's understand how this is going to be done. Suppose this is the k1 vector and this is the k2 vector. Now you can see the ends of this vector, that is this position, is going to be this one, that is the 3 is going to be jumped from this current position to this position. So let me write down their new vectors. You can see the new vector is coming out to be this one, k1, and this is going to be k2. Okay, so this will be our origin, let's say original, let me write down original vectors, and this should be our final vectors, which is our answer. Final vector, let me write down answer. So how we are going to convert this type of vector, which is our original vectors k1 and k2, to this orientation. Okay, note that k1 and k2 can vary to any lengths. Also k1 and k2 must coincide. Okay, so we need to just transform this k1 to this position and k2 to this position. Note that this k1, ends of this k1, which is over this position, must coincide with this ends of this array. Okay, so we need to transform this one. Okay, so how we are going to do is, let's suppose we have this k1 and let's suppose we have this k2. So first of all we will reverse this entire array. So if we will reverse this entire array, you can see my k2 would be something like this one, and my k1, note that this is actually the range. K1 and k2 always denotes a range, so it will be like this one, but we need to focus over there that this should be our final answer. So which says that we need to have k2 in the forward direction. Their arrows should point to the forward direction, but this is my current orientation, so it says that we need to reverse this part and we need to reverse this part. So if we are able to reverse this part and this part, then we are done. So let's reverse it one by one. So this should be our k2 and this should be our k1. Yes, you can see this is going to match with this one. Okay, so for any k1 and k2, like length, their length can be anything depending upon this value k. Then we can design a vector k1 and k2 such that they are going to coincide their ends. That is, the right end is going to coincide with the left end of this k2, and if you are trying to find out their new positions, k1 will always, that is the right end of this k1 will always coincide to the end of this array, and the left end is going to coincide with the right end of this k2. This should be our final vector. Orientations, we need to transform this orientation to this orientation. Okay, so we are going to do three operations. First, reverse this entire array, which will make the orientations of these two vectors k2 followed by k1, but their arrows are going to point towards left. But we can design these two orientations, like for their vectors k2 and k1, to point towards this direction if we will reverse these two segments. Okay, so note that the length of this k1 is always going to be n minus k. Okay, and there you can find out the corresponding length of k2 again. Okay, so we need to reverse the arrows very much efficiently, that is, reverse the segments of this array. So let's focus over there how we are going to do that. Yeah, so first I have taken this as modulus n. Okay, now the next thing that I'm going to do is like reverse 0 to n minus 1. So if you will reverse this 0 to n minus 1, you can see the entire, we are going to have this orientation, but we want this type of orientation. Okay, because the final modified array will have the values of will have the new positions at this type, which is going to correspond to the original position, that is this k1 is going to be shifted to this position. Okay, if we reverse this, we have the orientation of this type, but we want orientation of this type, k2 followed by k1, and the forward, that is, their arrows must point to the forward side, that is to the right side. So in that case we need to reverse this 0 to k minus 1, that is we need to reverse this entire thing. Note that length of k2 will always be equal to k. Okay, because length of k1 is coming out to be n minus k, and if you are not aware how this k1 length comes out to be, you can see k1 is going to denote a range which is from 0 to n minus k minus 1, and its length of this range is n minus k, that is k1. So correspondingly k2 have the length of k. Okay, so we need to reverse this part k2, so we will be reversing the index from 0 to k minus 1 followed by reversal from k to n minus 1. You can see then finally we are going to get this orientation, that is this one. Okay, so this will give you all test cases passed. So if you guys still have any doubts, do reach out to me to the comment section of the video, and thank you for watching this video.